when it comes to relays and so forth, right, the whole purpose there obviously is to go about, as you can see here, right, we have an attacker. We're going to then relay our attacks to the target through a machine or through a router or through whatever it is that we're trying to get through. And we basically would use Netcat to do so. And we'll try to explain a little bit as we go on through and so forth. And I'll try again to get you guys some ideas on some of the different things we can do and how we could do it. So anyway, a relay is a middleman through which an attacker can't interact. Different reasons is the attacker wants to obscure his location. Possibly. Right? The attacker's machine can only be reached through the middleman. Attackers also have some control over the relay machine in order to use it as a relay. Okay, so anyways, let's take a peek at some different types of relays we can do. We're about halfway through the module already, and here we're talking about doing a simple Netcat relay. And basically, when we're doing simple Netcat relays, right, you need basically a simple Netcat connector. The target views traffic coming from, in this case, our 192.168.3.10. Now, only one-way traffic from the attacker to the target. So traffic is sent by the target back to the relay, cannot be forwarded back to the attacker. And the command we basically use for that is, as you can see here, like NC minus NLP, 1, 2, 3, 4, 5. And then we use the pipe symbol. And with the pipe symbol, again, we're basically doing one-way communication. Okay, and especially in the Unix world and so forth. So what we're going to find out is we can actually use different options to get it to go both ways and so forth. And a lot of times for that, we'll use your FIFO. So anyway, so we basically are able to get in from one, relay the attack over to another. Again, we can have different port numbers we want to connect to and things like that. And there's lots of cool things we can do there. But we're going to take it a little bit further down. We're gonna basically take a peek into some other things. So we're going to look into some other type of scenarios. Now let me see here to make sure I'm not missing anything. So this example required you that you own the middleman, of course, already transferred Netcat to that box. This direction is called a relay. From the source computer, right? NC, host name of the relay, and then the port number. Now on the relay computer, of course, you do the -L, right? You do the -P, port number, whatever, pipe symbol, NC, host name of the target, and then the port number. In this case, 45321. Some basic scenario input from the source computer in the client mode is then sent to the relay computer in server mode. The output is piped into a second instance of Netcat in client mode, which ultimately connects to the target computer. Secondly, Netcat originates from port 1, 2, 3, 4, 5, yet the attacker would see the attack coming from port 54321. Simple case of port redirection. This technique can also be used to hide Netcat traffic in more common ports or change ports of applications whose normal ports might be blocked by a firewall. Right? This is an obvious limitation in the relay. The pipe data is a one-way connection. Therefore, the source computer has no way of receiving any response from the target computer. The solution here would be to establish a second relay from the target computer back to the source computer, thereby through another middleman. All right, and that's basically what we have there in the official verbiage for this slide. So next up, we have the newbie approach, and it tends to get a little messy, as they say. To begin with, the attack has to have two terminal windows open, one for typing commands, and the other one for checking the responses. Also, in the reply machine, the attacker is messy as he leaves one ST standard in and one standard out unused. Now, when we talk about some of these types of things, we basically get into what we call the name pipes. Okay. Now, name pipes, as its name implies, is a one-way or duplex pipe for communication between the pipe server and one or more pipe clients. All instances of a name pipe share the same pipe name, but each instance has its own buffer and handles and provides a separate conduit for client-server communication. To use instances, enable multiple pipe clients to use the same name pipe simultaneously. Any processes can access name pipes subject to security checks, making name pipes an easy form of communication between related and unrelated processes. Any processes can act as both the server and the client, making peer-to-peer communication possible, and so forth. Okay, all good there. It is also, by the way, a name pipe is also known as FIFO, fee, FIFO, FUM, right? The FIFO, first in, first out for its behavior. It's an extension of the traditional pipe concept on Unix and Unix-like systems, and is one of the methods for inter-process communication, as in your IPC. All right, the concept was back in the OS2 and Windows, Microsoft Windows, and it was traditionally named. Pipe is unnamed because it exists anonymously and persists only as long as the process is running, and that's the way we kind of came up with that whole null session and anonymous connection, and so forth that we had there. All right, so anyhow, so what we're basically doing is we're basically using different methods of getting the data, and as you can see here, we have a net client, right, with our standard in, standard out, and you can see the commands are associated with that, both for the target, the relay, and the target. The other thing is again here the name pipes, as I was just mentioning. So what we're doing here, I already mentioned with the inter-process communications and so forth. So let's see, the common methods used for inter-process communication: files created, then two processes can read write into the exchange data files, and a name pipe will then persist beyond the life of the process. Here they give you some examples, and these are going to be some of the things we're going to be using, like your make FIFO, and then your my pipe gzip -9 -c, for instance, and then your my pipe out gz. And basically, what we're going to be doing is instead of process shell independently, one could send data. For instance, you can, the first portion there that I mentioned creates a pipe and then sets up gzip to compress things, pipe to it. The second, your cat my file and such, is going to be within a separate process shell independently. One could send data to be compressed. The name pipe can also be deleted and so forth using, for instance, the rm command with my pipe. There's several ways for creating a name pipe, and the first two can be done directly from the shell, and you basically have the mknod my pipe and the mk FIFO. The above two commands perform identical operations with one exception. The make FIFO command provides a hook for altering the permissions on the FIFO file directly after creation. With your make nod, as in mknod, a quick call to the change mod command will be necessary. FIFO files can be quickly identified in the physical file system with the P indicator seen in a long directory listing. My FIFO with the P RW-R-. All right, so other things we got going on here. We have input-output stream. So most modern shell provides input-output redirection facility. There's 3 default standard files, which are going to be your standard streams, and we've kind of mentioned a few of these already. The Unix Linux standard with numbers. So you have your standard input, your standard output, and your standard error. And some common redirection of standard streams. So here you can redirect output to a file, right, using the command 1, for instance, or just putting command with the greater than symbol, and then the file, right, redirects output to a file. Command inputs comes from a file, because we're given that standard input. Redirect standard error and standard out to the file using the ampersand. We can also use command 2 to the file, which redirects the standard error to a file, or we can redirect the standard error to a standard output using the ampersand 1 as an option as well. So again, something to kind of take a peek into and see what you think, see what you like, and see if that will make any change.